here's 1D, log rules. So to get started, I've got some quick mental math problems for you here. So why don't you go ahead, just complete those real quick. Having knowledge of doubles, triples, and so on is important. Pause the video, quick complete those. Okay, you should get 7 times 7 times 7 is 33. 3 cubed is 27. 2 to the 4th is 16. 2 cubed, or 2 times 2 times 2, is 8. 6 to the 3rd is 216. 3 to the 4th is 81. 11 squared is 121. 2 to the 7th, big one, is 228. And 5 times 5 times 5, or 5 cubed, is 125. Okay. So we have a few different log rules here, and these are ones you've seen before in Algebra 2, but we're coming back to them here today. So the first is when you are adding two logs with the same base. So having that same base is very important. What you can do is you combine them into a log with the same base, but you multiply the insides. So log base b of m plus log base b of n equals log base b of m times n. Next, when you're subtracting, so when we added, we multiplied. When you subtract, you divide. So if you have the log base b of m minus log base b of n, you divide m and n into one log. Next, when you have an exponent on the inside of your log, you can bring that out to the front. So log base b of m to the power of k would be k times log base b of just m, which can be helpful for simplifying. Log base b of b, so when the base and what's inside the log is the same, you always get 1. Log base b of 1 is always 0, and log base b of 0, can't take the log of 0, that would be undefined. Okay. So let's get started here. So we'll want to use these rules as we are simplifying logs. So when we're simplifying logs, I have kind of some general things to remember. So the goal when you're simplifying is if you can end up with log base b of b, log base b of 1, or log base b of 0, that's really helpful. That's because log base b of b is 1, b of 1 is 0, and b of 0 is undefined. We have these clear answers. So some things you can do. You can try to substitute in exponents and then pull exponents out. You could apply addition or subtraction rules. You could try to substitute in exponents. Oh, we have the exact same thing here. Well, okay. So we have two things. My bad. Okay. So as we look at log base 5 of 25, so what we can do is our goal is to get log base b of b, so 5 of 5, or 5 of 1, or 5 of 0. So 25, is there a way I can represent that as 5 to the power of something? Well, log base 5 of 25 would be the same thing as log base 5 of 5 squared, since 5 squared is 25. And now what we can do is we can use that rule from above, log base b of m to the power of k equals k times log base b of m. So we can bring that exponent out to the front. So it'll just be 2 times log base 5 of 5, which we've discovered is log base 5 of 5 is just 1. So we get 2. Next problem, log of 10,000. So when you just see log written, this is called the common log. And that is the same thing as a log base 10. So this is the same thing as log base 10 of 10,000. It's kind of like how we don't put an exponent of 1 on things because it's like the most common thing or the base thing. Same idea here. So let's see if we can do that same idea, rewrite 10,000 as something 10 to the power of something. So we have 4 zeros, so that'll be 10 to the 4th. We can bring that 4 to the front. So we have 4 times log base 10 of 10, which again, log base 10 to 10, or log of 10 is just 1, which 4 times 1 is 0. The next one, log base 12 of 1, well, this is an easier one. Log base anything of 1, well, that's just 0. Okay. All right, let's do a few more here. So we have log base 4 of 16 to the 3rd. So I'm looking here, one thing we can do first is we can bring that 3 out front. So we have 3 times log base 4 of 16. Now I know we have a base 4, so if we can get 16 as 4 to the power of something, that's going to help us. Well, we may recall 16 is 4 squared, which we can then also bring that 2 out to the front. So we'll have 3 times 2 times log base 4 of 4. So bringing that other exponent, it multiplies, it does not add. So 3 times 2, so we'll have 6 times log base 4 of 4, which is 1. So we just get 6. Okay. Next problem, log base 2 of 8 plus log base 2 of 4. So what we could do is we can treat these separate. So you can figure them out as, so we have 2 options. So we could do this as just log base 2 of 8 first, which we know 2 to the 3rd is 8. And then also log base 2 of 4, we know 2 squared is 4. So again, we want those bases and what we're taking the log of to be the same. And then we bring the 3 out to the front. We bring the 2 out to the front for the other. So we have log base 3 times log base 2 of 2 plus 2 times log base 2 of 2. So 3 times 1 plus 2 times 1, or 3 plus 2, which is 5. So that's one way to do this. Another way we can think about this is in using this rule here, where we're adding 2 logs with the same base. So since these have the same base, what we can do, and they're being added, is we can multiply the insides. So there's 2 different ways. The other way we can think about this is 8 times 4 is 32. 32 is the same thing as 2 to the 5th, which you can bring that 5 out to the front then. So we get log base 2 of 2, which is just 1. 5 times 1 is 5. So we get the same solution. So you can do it either way. They both will work. Okay. All right, let's continue. So as we look at this one here, we've got log base 3 of 54, log base 3 of 2. So both 54 and 2 do not have, like, we can't take 3 to a power to get either of those. So doing it the first way we did the previous problem, probably not a good idea. So let's try it the second way. Meaning we have a subtraction, we have the same base, so when you're subtracting 2 logs with the same base, you divide what's underneath. So we'll have log base 3 of 54 over 2, which 54 divided by 2 is just 27, which now 27 sounds like a multiple of 3. 3 to the 3rd is 27. You bring the 3 out to the front. So we get 3 times log base 3 of 3, or just 3 times 1. So we get 3 there. Okay. Question? Well, if you have questions, you can email me. Okay. So we've got some more here. So what I'd like you to do, write down these problems. So we've got log base 9 of 81 to the 3rd. We have log base 6 of 216. And we have log base 7 of 0. And just try those on your own. Pause the video, give those a try. Okay, we're back. So when we're solving this one, you bring the 3 out front. 81 is the same as 9 squared. You bring the 2 out front, so we've got 2 times 3, which is 6, times log base 9 of 9, so 6 times 1, or just 6. Next, 216 is 6 cubed. Bring the 3 out front. Log base 6 of 6 is 1, so 3 times 1 is just 3. And lastly, log base 7 of 0, well, anything base of 0 is undefined. Okay. All right, I've got 3 more here that I'd like you to try on your own. These ones are a little more challenging, so do your best with them, and then we'll talk through them together. So you've got log base 7 of 49 plus log base 7 of 343. We have log base 4 of 64 minus log base 4 of 4. And we have log base 5 of 5 plus log base 5 of 1. So give those 3 a try on your own. Pause the video, try them. Okay, and we're back. So, 49 and 343. So two ways to go about this. We could multiply 49 and 343, or I'm noticing I know 49 is 7 squared. 343 is 7 cubed. So in this case, it's actually probably easier not to multiply because you bring the 2 out front, so 2 times log base 7 of 7, or just 2 times 1. You bring the 3 out front, or 3 times 1, 2 plus 3 is 5. Okay, next one. Log base 4 of 64 minus log base 4 of 4. Again, you could do it either way because 4 times 4 is 16 times 4 is 64. So it'll work either way, so let's just keep them separate. Actually, I'll put them together here this time just for review. So when you're subtracting 2 logs with the same base, remember you divide. 64 divided by 4 is 16. 16 is the same thing as 4 squared. Bring the 2 out front. So we get 2 times log base 4 of 4, or 2 times 1, which is just 2. Last one here. Log base 5 of 5. Well, anything with the same base and what you're taking the log of is 1. Log base 5 of 1, is 0. Anything base of 1 is just 0. 1 plus 0 is 1. Okay, not too bad. Okay, we've got 3 more here. These are what I would call challenge problems. So I'll list them for you. You can try them. Notice each of these will simplify to a log and not a whole number. So you just get these down as much as you can. So we've got log base 3 of 15 minus log base 3 of 5 plus 2 times log base 3 of 5. Then we have 2 plus 2 times log base 2 of 5 minus 3 times log base 2 of 3. And then on the back end, 1/3 log base 3 of 27 minus log base 3 of 81 minus 2 times log base 3 of the square root of 3. So you can try all 3 of those, pause the video, and I'll walk through them. Okay, here we are. So none of these are in a form where we can just change them to 3 to the power of something. So let's start combining these logs. So when you're subtracting logs with the same base, you divide them on the inside. So these will be log base 3 of 15 over 5, which is 3 there. Next we have this 2 times log base 3 of 5. So this will get us down to 1, but I would like for this all to be written as just 1 log, not a number. So to be able, even though these logs have the same base, to be able to combine them through addition, you can't have this coefficient out in front. So what we need to do is we need to bring it back in to the log. So it'll become log base 3 of 5 squared, which will be 25. So we'll have log base 3 of 3 plus log base 3 of 25. We multiply 3 and 25, and we get log base 3 of 75. Okay, not too bad. Next one. So here, again, we want to write everything as a log, so this could be kind of tricky. Again, we have two log base 2's here, so let's put them all together. So again, we need to bring these coefficients back inside to be able to combine these logs. We'll worry about that 2 later. So this will become log base 2 of 5 squared, which is 25, minus log base 2 of 3 cubed, which is 27. From there, we're subtracting two logs with the same base with no coefficient, so we divide what's on the inside, so we get log base 2 of 25 over 27. Okay, so I've got one log here. What I'd like to do is be able to combine these together. So one thing that we know about logs is that anything with the same base and what you're taking the log of is just 1. So this is essentially a 2 times 1. It's the same thing as 2. So what I can do is I can write this as 2 times log base 2 of 2. Bring this 2 in and square the 2. So we get 4, log base 2 of 4. And then now we've got the logs with the same base, no coefficients, so I can add these two logs together by multiplying the inside, which will give me log base 2 of 4 times 25, which is 100, over 27. Tough one. Okay. And the last challenge problem, and then we've got kind of one last thing I want us to look through. Shouldn't take us too long. So here we've got 1/3 log base 3 of 27. So the first thing I'm seeing is we should probably bring that as an exponent. So 3 times log base 3 of 27 to the 1/3 minus log base 3 of 81 minus log base 3 of root 3 squared. So remember, so let's see, 27 to the 1/3. Same thing, remember, as a cube root of 27. So is there anything that multiplies by itself 3 times to get to 27? There is. 3 times 3 times 3 gives us 27, so that means the cube root of 27, well, that's just 3. Okay, keep going here. Here we have log base 3 of the square root of 3 squared. Squared and square roots cancel, so we just got 3. Now as I'm looking at all these 3 terms, we have log base 3's for all of them, and all of these should be able to, we can take 3 to a power to get each. So log base 3 of 3, well, that's just 1. Log base 3 of 81, well, 3 squared is 9, to the 3rd is 27, to the 4th is 81, and log base 3 of 3 is 1 again. So we've got 1 minus, bring the 4 to the front, times log base 3 of 3, or just 1. So 1 minus 4 minus 1, well, that just gives us -4. Okay. Kind of complicated. Those are our challenge problems. All right. Last thing we want to do here is just talk about expanding logs. So expanding logs is something that can be really beneficial when you are trying to simplify. We did a lot of condensing to simplify, but expanding can be helpful as well. So our goal is to have as many separate logs as possible. So for number 1, we have log base 3 of 3x squared. So what I'm noticing here is we're multiplying 3 and x. So if we think about some of these rules that we were using, when you have two things multiplied, that's the same thing as adding those two logs with the same base with whatever you're multiplying. So when we're adding two logs, we multiply the inside. So if we're multiplying the inside, we can separate it into two logs through addition. So we're just doing the reverse of these rules we started with. So log base 3 of 3x squared could be written as log base 3 of 3 plus log base 3 of x squared. And from there, there's nothing more we can do here. In this sense, if we are simplifying further, the thing I would like you to do is to bring that 2 to the front, because it does feel like it's expanded a little bit more when you've got that number out front rather than as an exponent. So we've separated it into as many logs as we possibly could have. Okay. next here, log base 6 of x to the 1/2, y to the 7th, over 4z to the 9th. So we could think about this as all over 4z, or sorry, squared. Let me rewrite this here just so it looks a little cleaner. So log base 6. So when we're dividing anything, remember division is the same as subtraction between logs. So let's just separate it along with division. So that would give us x to the 1/2 y to the 7th minus log base 6. So keep the same log base of 4z squared. Okay. From there, we have two variables in each, so we should be able to separate those. So this will be, since they're multiplied, they're separated by addition. Same thing here, since they're multiplied, they'd be separated by addition. However, you gotta be careful. Since we're subtracting this whole log here, we should keep that in parentheses, because those two should be subtracted as well. Last thing we can do is just bring those exponents back out to the front. So that would leave us with 1/2 log base 6 of x plus 7 log base 6 of y minus log base 6 of 4 and minus 2 times log base 6 of z. So this becomes a minus because, so we brought that 2 up front, but you got to distribute that negative to each portion to make sure that you're expanding correctly. Okay. All right, and that is it for today. That's all we'll do for 1D, or log rules notes. So the most important things, make sure you remember these rules. Those are very, very important for logarithms, as well as how to simplify.